Hi. In the binomial expansion of 2x plus 1 all over x squared to the power 6, what is the constant term? 120, 480, 30, or 240? The solution I have to propose here, we're going to work with the binomial theorem, which says that if we have a binomial to the power n, then that will be obtained if we carry out the expansion a to the n minus r, b to the r. Okay, a is the first member of this binomial and b is the second member. So what we need to do is to first of all arrange this to this nature. Here we don't have fractions, and so 2x plus 1 all over x squared to the power 6 can be rewritten as 2x plus x to the negative 2 to the power 6. So that here, our a here is 2x and our b is x to the negative 2 and our n is 6. So by the binomial theorem, 2x plus x to the negative 2 to the power 6 by our binomial theorem will be equal to this series 6 combination r. Our first term is 2x to the power 6 minus r, and our second member is x to the negative 2 to the power r. Okay, so from here we can bring out our general term ur. Our general term ur is 6 combination r, 2x to the power 6 minus r, x to the negative 2r, and we multiply this power and that power. So we can continue our arrangement. We bring out 2 and x share this power. So 2 to the power 6 minus r, x to the power 6 minus r, and then x to the power negative 2r. Alright, this gives us 6 combination r, 2 to the 6 minus r, x. Now, we have this index expression multiplied to this index expression. Since the bases are equal, so we have to add the powers. It becomes 6 minus r minus 2r becomes 6 minus 3r. Okay? Now, to get the constant term means that term that does not have the variable x. Alright? So for the constant term, the variable x has power 0. The variable x has power 0. So to get the r that we needed to generate that constant term, we have to equate. So we equate x to the 6 minus 3r to x to the power 0. This index expression equals that index expression. That can only happen if the powers are equal. So from here we see that 6 is equal to 3r. When we take negative 3r, that will become positive 3r. To have r, we simply divide both sides by 6. Therefore, the r that we require is 2. The r that we require is 2. Now, to get there for that constant term, we have to put the value r in this expression of our constant term, of our general term. Sorry, we put the value r in this expression of our general term. That will give us a term that is independent of the variable x, which is also known as a constant term. Alright, so let's do that. Our general term again, ur is 6 combination r, 2 to the 6 minus r, x to the 6 minus 3r. So when r is 2, that term now becomes 6 combination 2, 2 to the 6 minus 2, x to the 6 minus 3 times 2. Okay, this gives us 6 combination 2, 2 to the power 4, x to the 6 minus 6. And 6 minus 6 is 0, and anything raised to the power 0 is 1. So that term will just be 6 combination 2, 2 to the power 4. So you can see, alright, you can see there's no x anymore in that term. So we are going to obtain the constant as required. Now what is 6 combination 2, 2 to the power 4? 6 combination 2, 2 to the power 4. 6 combination 2, 2 to the power 4 is the same as 6 factorial, all over 2 factorial, 4 factorial. All of that multiplied to 2 to the power 4. Now this gives us 6 times 5 times 4 factorial, all over 2 factorial times 4 factorial, all multiplied to 2 to the power 4 is 16. Now 4 factorial cancels 4 factorial, 2 here 1, 2 there 3. So this finally gives us 15 times 16, which when we check very well, it is 240. So the constant term for this binomial expansion will be 240, and our answer is the option D.